Good afternoon, everyone, and welcome to this session 5BB of the GSE UK November conference. Today we've got Roland Koo. He's going to give us his take on using open source languages to modernize business critical applications on zOS. In terms of questions, please post them in the chat and we will ask them as we go, or maybe cover a couple at the end. So Roland, with that, you have the floor, sir. Over to you.
Thank you. My name is Roland Koo, and I lead the product management team for compilers on zOS and also enterprise products. And today I'm going to be talking about the entire programming language portfolio on zOS and especially the exciting new languages that we enabled on the platform to help you modernize your business critical applications. So this is call out to support the charity that GSE UK conference supports. So it's all going to good cause. So hopefully we'll get your support as well. So the topic, the big topic for today is really to tackle digital transformation, right? It is happening, everywhere as businesses are integrating digital technology into all areas of the business. Right, and this is a really good drive for innovation, but it's also driving a lot of requirements at very fast pace, for the development teams. So we just wanted to make sure that we have enough tools or give you the options so that when you're dealing with your application itself, you have the you'll be able to pick and choose what is best for you, for what you want to do. Right, so this is what this session is all about. As software development teams, we often face the biggest challenge, two biggest challenge here. One is we have to develop new applications, and the application and the number of new applications and cost of maintaining existing application is really skyrocketing. IDC estimates that there's about 500 million new applications going to be written from 2018 to 2025, and 40% of what we have shipped today has technical debt. So the challenge for our organization is to be able to manage all these challenges, right? So for your modernization strategy, it is important to reuse existing core applications, right? Extend them with new ones. So when we do that, then we can minimize the risk, the cost, and also the time to market, right? Time to deliver these applications. So the IBM approach to building and modernizing application really maximizes the agility and ROI because we look at the strategy and the roadmap, we look at optimization of core applications, and then we deal with application development and access and everything else. So basically, it is a very comprehensive approach to modernizing the business critical applications, especially on the zOS platform. So when we talk about modernization, for us on the Z platform, we actually have three aspects that we look at, right? One is you want to make sure that the application itself today, your business critical application, is running optimized, is optimized to run on the platform. That means they can take full advantage of all the hardware features that we put in, right, to the Z hardware. So this is really, this means that you really have to stay current with the compile technology, so that you can take advantage of you can take full advantage of the hardware that you've invested in. Then you talk about modernization. There's two aspects to it. One is you can look at extending your existing applications with traditional traditional languages. Like if you have a COBOL applications, we constantly put in new features in the COBOL compiler to help you extend your application, so you can actually take advantage of that. That is also true for PL1 and C and C++ and Java and things like that. You can also, obviously build new applications with the new languages like Node.js, Python, and Go, which we recently enabled on the zOS platform. And of course, a lot of the interaction between the different program developed in different languages, you can either use APIs, to make them work together, or you can use interlanguage calls, which is also valid in this environment. So I just wanted to talk a little bit about the roadmap for the IBM Z hardware and how it deliver application performance, on that platform. IBM Z actually now delivers performance improvement with a combination of hardware features and compilation technologies. That means that the compiler development team and the processor development team are really extended teams of each other. We look at a certain workload, and we know that we cannot increase the clock speed forever. So what we're doing is to really co-create some new hardware features and put in new instructions so that the compilers can exploit them. And therefore, if you recompile with these and optimize with the latest compilers, you will be able to take full advantage of those hardware features. So I just wanted to talk, give you an example of what I was just talking about. When we look at the Cobalt and PL1 workload, right, we actually have designed new features in the IBM Z processor to help improve the performance of these workloads. And this roadmap actually started way back in the Z10 timeframe, where we put in the first feature that we put in was the decimal floating point unit. Because we know decimal arithmetic is not, it's often, it is very convenient because it's, it's decimal, but it is not handled very efficiently in the system. For example, if you are looking at a zone decimal arithmetic where for COBOL programmers, it is PIC9 arithmetic, you really don't have any arithmetic operations or hardware to handle these, these calculations. Often you have to translate those zone decimal arithmetic to packed decimal, and then, after the processing, it gets translated back. So as you can see, this, kind of translating back and forth and using very, memory-to-memory instructions, it incurs a lot of, it actually inherits a lot of overhead in terms of these calculations, and these calculations are done very often, in the programs, right? So in the Z10 timeframe, we put in something called the decimal floating point unit. Basically, it is to accelerate these kind of calculations, because it has its own registers, it has its own arithmetic operations to deal with these calculations, so the calculations can go a lot faster. So unfortunately, if you have to take advantage of these, these features in the Z10 timeframe, you will have to rewrite. You have to actually put code into your programs to be able to do that, right? So what happened is that in the EC12 timeframe, right? Fast forward a couple of years, we put in a facility called the Decimal Floating Point Zone Conversion Facility. So basically, we would put features in the hardware to automatically convert your zone decimal arithmetic over to, to decimal floating point, so that the entire calculations can be done on the decimal floating point unit, right? And then, that means that your PIC9 arithmetic will go a lot faster. And then on Z13, we extended the same idea, but to include the packed decimal. So we also convert packed decimal arithmetic or data types over to run on the decimal floating point unit. And on the Z13, I think one of the major features is vector extension facility, means that we're actually generating SIMD instructions, basically vector instructions. So COBOL also can take advantage of this code, this facility for some string manipulation type, calls, processing. So yeah, the 60-year-old COBOL language now can actually generate vector code. So on the Z14, we improved that, the handling of pacdecimal by putting in something called vector pacdecimal facility, because we're still not happy with the decimal floating point and handling of the pacdecimal arithmetic, because there's a lot of memory-to-memory instructions being involved there. So in the Z14 timeframe, what we did was we actually get rid of all these overhead, because we are using vector registers to do those pacdecimal calculations. And now in the Z15, we enhanced that facility to basically fine tune it to get better performance. And then we added the facility to reduce the overhead for interlanguage calls having, exception, coming back, overflow exceptions coming back from the calls. So as you can see, we're progressing, with new hardware features all the time, right? The roadmap, and currently we're actually working with ZNext and ZNext plus one. We actually are looking into about 2 generations ahead. So that's why this is in the roadmap. And if you're not able to take advantage of these, these new features in the hardware, then you're certainly not getting, a very good return on investment on your hardware. So I want to take a 10-second pause here to see if there's any questions.
All good for now, Roland, carry on.
Oh, perfect, thank you. So here's the latest compiler offerings on zOS. So we have the COBOL compiler, which has been around for a long time. And we also have an optimizer product that automatically optimizes the binaries generated by the COBOL compiler. It's called Automatic Binary Optimizer. And we have PL1, we have C and C++. This is really on the traditional side. On the newer side, we'll consider Java a little bit. It's still on the new side because it's still a young kid of about 20 years old. And then we bring in the really young guys like Node.js, Python, and Go, all natively now running on the platform. So as you look at it on the zOS platform, if you look at the most popular languages that are listed by IDC in their platform as a service view and the developer report in 2020, we have really, really good coverage there, right? You can actually see Java, C++, Python, COBOL, Node.js, Go. Those are amongst all the more popular languages, and now they're all natively available on zOS. So now I just wanted to talk a little bit about the compilers itself, and if you have any, please put in the chat if you have any questions about them. I also wanted to, these 6.3, for example, some of these compilers are have been available for some time, but I wanted to also highlight the some of the enhancements that we put in there that are significant. And as you know, that the compiler now is adopting a continuous delivery approach, where we will be rolling out new functions in PTFs as well. So here's, for 6.3, this is the latest COBOL compiler. We put in native support for UTF-8, right? So now you don't have to go through a translation to UTF-16 again, because a lot of people actually store UTF-8 data in a database. So every time they want to bring that data up from the database and process it, before this support, it's a little inconvenient, because you have to go through UTF-16 and convert back and forth and stuff like that. One of the themes that we also are doing with the COBOL compiler is to enable new language support for that, for the language. So there are some new language features in the standard that we're bringing in, and this time we're bringing in the dynamic length elementary items, because as we are moving into a more modern world, it's very hard to exactly know what length of these data items are. So we're trying to add, some more flexibility so that, you can have an easier job in modernizing applications. Another big feature that we have delivered in 6.3 is 64-bit support. This is the first delivery of the 64-bit support. 64-bit is all about data addressing, right? So we know that we have to process more data, so the addressing space of of 2 gigabytes is getting a little bit, we're stretching that a little bit. So with 64-bit, you should be able to have more addressing space. So with 31-bit programs, your addressing space is currently limited to 1 gigabyte. But with 64-bit, you can get up to 2 gigabytes, but you can have multiple data items that you're addressing at the same time. So we're going to continue to work on this to make it true 64-bit, so that we can take out that 2 gigabytes limitation. But the first delivery will give you all, a lot of flexibility there. Since then, recently, actually a month ago, we provided support for dynamic calls between 31-bit and 64-bit COBOL programs, because as you are, trying to modernize the application to handle more data, right? You can't. But most of you can actually write a 64-bit application to handle that, but the rest of the application is going to remains in 31-bit. So with this facility, you should, you are able to have, interactions between 31-bit and 64-bit COBOL programs. So you don't really have to rewrite a lot of 64-bit COBOL program or make them separate as you, require more addressing space. We also have put in the support for 31-bit COBOL programs calling 64-bit Java programs, because currently, a lot of customers are using 31-bit Java simply because, these programs need to interoperate with COBOL programs. So this is no longer the case, because we know that 64-bit is the norm now for Java programs. So now you can actually use 64-bit Java and have 31-bit COBOL applications interoperate with it. So just want to briefly talk a little bit about the automatic binary optimizer. This is a binary optimizer, so it doesn't need to compile from source, like it doesn't need source at all. It will just use the compile code or the load modules as an input, and it will optimize that load module to the deployment hardware to the hardware that you're deploying your applications to. So it targets the later Z systems from EC12 to Z15. And it is complementary to COBOL 6.3 because, as we know that migration is needed to move from COBOL 4 to COBOL 6. And migration usually takes a lot of testing and all that is because there's some existing source problems that you need to fix, right? So with ABO, you don't need to do that. And it totally avoids the source recompilation. Because there's no recompilation, it also can reduce the testing effort. And also, it gives you a similar performance advantage as the same performance improvement as COBOL 6. So since we have shipped version 2.1 of ABO, we added a new feature there because we know that there are some challenges trying to determine which modules to optimize. Because usually COBOL applications are very big and they have many, many modules. And we do not recommend that you go and blindly optimize everything. So we suggested a way that involves performance analysis and things like that, but that gets a little bit more complicated. So what we did was we put together something called the ABO Assistant, which is a suite of tools that help you get concrete performance evaluation results from ABO. It's really good for doing POCs or even help you deploy ABO as well. So it uses SMF record, and it is able to look at the SMF record and then select the application programs that has COBOL content in it. Because remember, ABO is a COBOL optimizer. So so if you are spending time in, spending a lot of time in Kix or in assembler, ABO is not able to optimize those codes. So this SMF analyzer would select the programs, and then it will go through the analysis phase from ABO, and then it will sort out the programs that has high CPU consumption in a COBOL sense, and then it will optimize it, and then it'll run the application and give you a report, before and after report. So it's a pretty neat tool for doing proof of concepts. So ABO and COBOL 6.3 are complementary. They're not competing technologies, because as we know that a lot of our customers told us that they will only compile programs that require source changes. So basically that are under active development and maintenance, right? So the rest of it, it just works, and they don't really have plans to recompile them. But as you know, if you wanted to to compile it with version 6.3, and you're currently running version 4.2, you will have to go through a migration process. So that's why that's where ABO comes in, because you're not changing the code is pretty static. ABO can very quickly optimize those programs for you, and then you can just concentrate on making 6.3 as your production compiler, and just scope it to compiling the code that you normally compile, because these code you also know a little bit more about them, so that it will significantly reduce your migration time. I'm going to take a pause here to see if there's any questions.
I have one question, Roland.
Yes.
Is there a way to estimate the potential benefit of deploying ABO before you deploy it, or is that one of the functions of the assistant?
Yeah, that is one of the functions of the assistant. Okay. So that obviously we would recommend that you do a POC so that you actually know. A lot of people look at the job as say this job is consuming a lot of CPU, but it is a COBOL job, but it doesn't really have a lot of COBOL content in it, and then it is not a good candidate for ABO. Yep. So ABO Assistant will be able to help you sort that out. That's exactly why we put it in for.
Got it. Thank you.
Yeah. Okay. So I wanted to talk a little bit about C++, especially the new direction that we are embarking on. C++ is part of zOS, is optionally priced feature of zOS, right? So it is, you enable through the zOS enablement. So we are actually, but this compiler is a little bit, behind in terms of language standard support, because the C++ standard is moving so fast that it's very hard to keep up. So what we're trying to do is we're actually transitioning to an open source framework, which is based on LLVM. So the first step that we did was we make a web deliverable that is based on the Clang technology. Clang is really the front end part that handles the language. So basically, what we did was we transitioned to a new front end, which basically will allow us to, which would give us, more up-to-date support for the C++ standard and the C standard and everything, right? But we're still using the IBM backend technology for it, and we made it into a web deliverable. which if customers, who are licensed, who have enabled the C++ feature on zOS, this web deliverable is free for them. And it is a 64-bit only compiler, and it only runs on a USSI for now. So what we're trying to do is we wanted to go all the way with LLVM infrastructure, because this will basically give us a little bit more diagnostic capabilities and a little bit more closer to the open source implementation. But what we're concentrating on doing now is, instead of looking at the front end and part of the back end, we'll concentrate on putting together the advanced optimization technology. So we will try to, the objective here is to provide the best of both worlds to our clients, so that they can have the most up-to-date language standard to, because we know that language standard is very important, especially a lot of people are enabling open source applications on zOS, and without that support, it's very hard to do, right? Also, the CLI is a little bit different between the IBM compiler and the open source compiler, but all the make files, all the things that you see when you try to enable these applications are more on the open source side. So with that, we actually are getting a lot closer to the to the rest of the community. And we're actually going to be a good citizen of this community as well. So meaning that we actually are contributing code to this open source community, to the LLVM community, instead of just, we're not just taking things from that, but we're actually contributing back as well. So we're actually upstreaming our changes for zOS up to the community, so everybody can take advantage of that. So this compiler, it's in the full LLVM enabled compiler, which we will call IBM XL, OpenXL C and C++, is going to be, the beta program has started. So please contact me or Robert Barrington, who's the product manager for C and C++. We'll be happy to, to work with you on to get you on the beta. One other feature of the C and C++ compiler is the ability to modernize assembly applications. It has something called Metal C support. So we know that it's very hard to find good and experienced assembler programmers in the market anymore. So what we're trying to do is to make use of C syntax and make it available to you, so that you can actually develop system programs that are independent of LE. So you can actually write very high performance code that is similar to assembler, because using C syntax means that the compiler will still generate assembler code, right? So it is completely compatible with the existing assembler code, so that you can actually embed it into the existing applications that you have. So you don't have to rewrite everything or convert everything, to use this feature. The good thing about this, the best thing about this really, is that you only need to write the application once, and let the compiler generate the optimized assembler code for you. So you always be optimized wherever you go, whatever hardware you upgrade to. I wanted to briefly touch on PL1. We're still working on PL1 because, every year we got a couple of emails, asking if PL1 we're still working on PL1. The answer is absolutely yes. And in fact, we are, PL1 is as up to date as COBOL in terms of Z architecture support. And we are actually right now investing in new optimization technology for PL1. This means that we're actually putting in the optimizer for COBOL, enabling it for PL1 as well, so that we can have, common support, and so that, for the hardware. So the biggest thing about PL1 is that it is really, the requirements are really customer driven. So they have the most RFEs for every compiler, compared to other compilers, and the team is very responsive to those requests. So I want to take a pause here before we go into the modern languages. Any questions here?
Nothing in the chat, Roland. All good to carry on.
Perfect. So, a lot of customers are asking, why are we looking at Python, Node, and Go, and why do we want to enable it onto the Z platform? Well, we just wanted to, take advantage. We're dealing with digital transformation, right? And a lot of customers are using these languages already, probably not on the zOS platform yet, but they're actually using it on other platforms and interface, and try to work with the data and everything that's stored on zOS. So when we look at that, we say, hey, why not, enable them? And plus, we might have some use for it as well internally for IBM. So what we want to do is to take advantage of the very popular and growing programming languages and enable them to IBM Z, so that you will have more options for your digital transformation needs. So that you can find the language that best fit what you want to do, and you can deliver your applications very quickly. And most important, also another very important point is that there's a lot of skills out there in the market, for these languages. And when we enable these languages, we're going to be, staying current with the community. For example, Python should look exactly the same as Python everywhere, so that you can use the talent pool that that the market has, and have them work on zOS as well. And a lot of these languages have a lot very good ecosystem of packages that you can instantly use in your applications, and that's really why they were so popular in the first place, right? So we look at the number of developers worldwide. This is I think based on the an IDC projection. It is, if you look at 9 million for Java, 8 million for Python, 7 million for Node, and 5 million for Go. There's a lot of talent out there that we can actually, use to modernize applications on IBM Z, right? So internally, IBM offerings also require these, these languages as well. For example, Python, it's almost like a de facto language for Ansible. So that's, we're going there to support Ansible and ZOAU, and also something called Isoda, also required for data scientists, also uses Python. And Node.js is being used in WASI and Zoe. And Go is very important for the platform because we are working on container runtimes and Kubernetes orchestration for zOS, and that's all coded in Go. So we're also using it as well. So we wanted to make sure that, this is really why we want to make sure that we're also always up to date with the community, so that we can also leverage the good technology that we enable on the platform. So all these products are available in Shop Z, and they don't have any license charges. But if you want, service and the ability to report defects, you can actually purchase SNS, but that's optional. So what that means is that you can order these languages free of charge, free of license charge, use it in your system, on your system. You can deploy them. This is not a evaluation license. This is a production license. And if you need SNS, you can always come back and enable SNS. So we know Java has been on the platform for a long time, and Java is, one of the most important languages on the platform. And when we announced Z15, it has a lot of features that's there. It fully supports the platform. Similar idea to COBOL and PL1 and C and C++. Java also work very closely with the processor team, so that they actually can provide full support for the 30+ new instructions on Z15, right, to accelerate a lot of the activities there, especially crypto APIs. And it supports compression. The compression went from on a card, compression card to on chip on Z15, and Java is able to fully support that. And on Z14, we have this new facility that allows the implementation of pauseless garbage collection to improve the garbage collection time, because one of the biggest challenge for Java application is when the garbage collector kicks in, you never know how long it's going to take them to finish the job. So with this pauseless garbage collection mechanism, we can actually do more frequent garbage collection in a smaller scale, so that we can get better throughput, and that is also improved for the Z15 as well. Also, one of the major features of Z15 is system recovery boost, and the JVM now supports that as well. So it scales very, very well. It adopts very well for changing system resources, capacity, and things like that. So this Java implementation on Z15 is still based on Java 8. A lot of customers are asking us, when are we doing Java 11? We're actually working on Java 11 now. We're close to announcing the Java 11 support for zOS, and we're looking into two phases of delivery. One is the language support, so that people can actually use the Java 11 language specification, and the second phase is going to be the security components, which we're working on and intend to deliver later. So the Java 11 beta test beta program has started. So if you wanted to join, please contact me or James Tang, who's the product manager for Java on my team. So is there any questions for Java?
Nothing in the chat, Roland. Perfect.
Okay. So let's talk a little bit about the, let's start with Node.js. Node.js is, it's really very widely used applications. And the reason is because its popularity is actually driven by the number of NPMs or node package modules that are available, for people to incorporate into their applications. They have by far the biggest ecosystem for, as far as all modules are concerned. And it provides a very module-driven and high scalable approach to application design and development, so that, it encourages, agile practices. It is really a server-side JavaScript platform. The programming language for Node.js is JavaScript, and the usually JavaScript is a web. It works in a web browser, but with Node.js, you actually take the runtime from the web browser and put it onto a server, because it has non-blocking I/O design and has a lot of bandwidth for I/O. Is really great for developing, handling I/O applications. And as you can see, that it is really good match for the Z platform, because Z is also very good in dealing with IOs, right? So those really are perfect match if you have really good big IO applications and you want to do it very quickly. So when Node.js came out, it was really used by the startups, but now it's more and more what we found is like it's being used by a lot of enterprises, specifically for modernizing applications, so writing new capabilities, right, to add to the business critical applications. So our implementation is very up to date. It is based on Node.js version 14. Which comes with a new version of V8 JavaScript engine and worker threads and things like that. Those are new features that added into V14. We are working on v16 now. The delivery strategy here is that we will pick up all the long-term support or the LTS, addition of the community. Sorry, LTS for the community edition, and we will make them and we'll enable them on the platform, right? So usually the even number versions are LTS versions. So the next one is 16, and we're working on them right now. And this product actually, you can choose whether you wanted to do a PAX install. There's a PAX download as well as an SMPE install. So we, with the SMPE install, we included restricted use CNC++ compiler for you to install the NPMs, because some of the NPMs are shipped as C or C++ source code. So you will need a compiler to do that. And we don't think it's fair to prereq the CNC++ compiler in the operating system. So what we do is we actually do package the CNC++ compiler that built Node.js and make it available for you to install NPMs. So remember, this is a restricted use compiler, so you shouldn't be using it for general CNC++ application development. For that, you should be using you should be enabling it, the feature in the operating system. So this product runs on ZEC12 and later, and zOS 2.3 and later as well. So it will not be very useful if we, Node.js will not be very useful if we, you can't access any zOS assets, right? So we actually have a list of NPMs listed here that allows you to work with different, assets on zOS. First of all, it works with zOS Connect because Node.js speaks API very well, and and with this with this NPM, you can actually access zOS assets that are exposed through zOS Connect, and you can also produce APIs with loopback connector as well. For Kix, it is interesting because Kix actually enabled Node.js as a programming language. So what you can do now is, instead of using, if you choose to, you don't have to use Java or PL1 or COBOL to write programming logic for Kix transaction applications. You can actually use Node. So what it means is that the Node.js application will be running in the Kix region, so, the same way that it, same way as Kix COBOL or Kix Java applications. There's NPMs that allow you to access DB2 data, VSEM data, and work with recs and work with recaf and keyrings and things like that. So that this list is not the final list. So we're taking requirements. So if there's any things that you need, we're still building on this list of NPMs that allows you to work with zOS assets. So use cases, obviously, co-location is very important because we have a lot of customers that are already using Node.js, but it's using it outside of the zOS environment, and for that you need to rely on the network to connect into getting data from zOS. So co-location is the biggest advantage there. We're not asking you to move everything onto zOS, but where it makes sense, where it can actually help throughput, help reduce latency, that kind of stuff, it's really a good thing to do to move it on, to run it onto zOS. API orchestration is also a very big area that a lot of customers are looking at, because orchestration doesn't mean simply managing the sequence of calls, API calls, but sometimes you have to put some business logic or programming logic to it, and Node would be very, very suitable for doing for adding logic into the API orchestration, handling of API orchestration. So basically, you can leverage all the reduced latency and security and everything that's on zOS, and then you can use it to orchestrate APIs. Obviously, application development and modernization, because we can definitely take advantage of the large ecosystem of NPMs to help you reduce your development time and cost. And also you can, use this because of APIs and, and all that, and also the Kix integration, you can actually extend business critical application, to support your digital transformation initiatives very quickly. I want to talk a little bit about Python. Obviously, we all know that Python is one of the most popular and the fastest growing programming language. It is very simple. It's almost like a Swiss Army knife for programming languages. It can either do data science applications, ML AI applications, or you can actually use it for scripting. So it's a very there's a lot of usage to Python. So our Python implementation is based on Python version 3.9 from the Software Foundation. It is because Python is mostly a C application, so it is a zOS LE based. It is 64-bit only. It runs on USS. It doesn't have any prerequisites. You can install Python pretty independently, and it supports ASCII, ABCDIC, and UTF-8 character sets. So, obviously we will have to include the CPython interpreter, which fully supports the latest C architecture. And also we support the Python standard library, and we added some PyPy packages there, the more popular ones, about 8 of them in there, and it has the PDB debug support all built in. So it's a very complete implementation of Python on the platform. So in terms of use cases, obviously it is the de facto language for programming Python, Ansible playbooks and things like that. So that, if you wanted to use Ansible to streamline your operation for deploying into a hybrid IT environment, you're going to be using Python for writing those logic. And also it's for data analytics. So IBM has a product called IBM Open Data Analytics for zOS, or IZODA. They actually provide data scientists with comprehensive Python solution, for doing their data science applications. So Python is key in this, in this usage as well. If you're using data sets and you wanted to program Python, you can actually use the Z Open Automation utility. It has great Python support, and Python itself runs on the USS side. But if you wanted to work with more traditional NVS side, ZOAU is really a very good way to go, and it's also free. So, and also Python, as I mentioned, is a very good scripting language. So automating builds, automating DevOps or system management, a lot of customers are using that. And also, obviously in modernization, you would, probably develop some new applications. And you can also make use of the ecosystem of packages, which is mostly, a lot of that geared towards the data scientist side, and provide, and basically, provide a different view with a different set of data, to your business critical applications as well. So IBM Open Enterprise SDK for Go. This is the latest product that we enable on the platform. We only enabled it on, March this year. So Golang is, out of the 3 new languages, this is the only compiled language. So it's really a compiler. So really, it's a full enablement of the Go compiler on zOS. So it has complete support for the Go standard library. Supports UTF-8, multi-threading. Go is very good for concurrent programming, and those are kind of things that we are, some of the infrastructure type applications are, requires. So it's really good for that. And if you wanted to interface to other languages, there's a facility called cgo, and that's also enabled on the platform. So, we also enhance support for the IBM Vector and the crypto libraries as well. So this is our first delivery, but we are going to be staying on top of the community as well. And this implementation is based on version 1.16, and 1.17 is currently what we're working on as well. The advantages of that is, it's also, big co-location thing, right? So instead of having some applications that make sense to be on the platform co-locating with the IBM data and application assets, that's really one of the biggest advantage of having that on the platform as well. So the latest announcement is we have a debugger support for Go. So the latest IBM debug for zOS version 15, which is also available through the IDZ product, which is IBM Developer for Z, and also ADFZ product as well. So Z, version 15 has Go support, and we're very happy to do that. This just announced, I think about a month ago or a few weeks ago. And for more information, there's a link to the blog here that actually takes you through a very simple example of how you would debug Go applications. So use cases, obviously, a lot of customers are looking into developing new APIs with Go, with Golang, and they're building APIs, plugins, or wrappers to extend the business critical application as well, and they will write new applications on zOS, just like us. Like we're working on the the container runtimes and stuff like that, and we also with zOS Connect, we can also work with middleware applications as well, and we can develop very fast, lightweight application. And remember, this is the compiler product, so you don't really have to ship source with, it's not interpretive, and it can actually be a little bit more lightweight and performs better on the platform. So I just wanted to put it all together with my last presentation chart here, as to give you a possibility as to how you can modernize. There's some options that you can modernize that you can use to modernize your business critical applications. So we start with some a typical business critical applications that's either written in COBOL, PL1, Java, or C and C++, and it may use some middleware like IMS, TM, and Kix. And you may want it to also use vSAM, DB2, IMS database, right? So it's very typical, application that you start with. Then you look at, some PL1 and COBOL applications may work with some, may have to work with some assembler code, and some COBOL applications, you might have already started using Java to extend it, and to modernize assembler code, we actually have something called Metal C that you can actually use, and they're fully compatible. As I said, you don't really have to do a lot of conversion. You can just simply, add on and build on it. And with COBOL, like a lot of customers are adding some user interfaces and some UI type capabilities that started to use Java. So now we have Node. If you use Node, Node now becomes an option if you wanted to write some simple reports, or you wanted to, get some data from multiple databases and things like that. It's going to be, it's very easy to write those applications and deliver it very, very quickly. Obviously, these applications can also be written in the traditional languages, but that will take a little bit longer because you have more code to work with, and the testing and trying to figure out where to insert this code. Sometimes it could be pretty time consuming. And as I said that before, that Node also is a programming language for Kix, so you can now write Kix transaction applications with Node as a language as well. Then you obviously can write new insights, new applications for in Go and Python. And if you wanted to interface it back to the traditional applications, you can use APIs, and those APIs are usually exposed with zOS Connect. So I talked a little bit about orchestration. So when you get some API requests from outside of zOS, you can actually use Node to very conveniently handle the orchestration of these API calls, so that you can actually match up, return the exact data that the API is calling for, and not giving them any more, any less. And the neat thing here is also that the people outside, the applications outside of zOS, doesn't have to know the application structure that is on zOS, and this will let the zOS people, the developers, handle these requests. So all they need to do is say, okay, I'm calling this I want this API, and I wanted to get this data, and then Node will handle the rest for you. So it's just as you can see, this actually opens up a lot of possibilities for you to look at to handle modernization on the platform. So there's a lot of information today that we talked about. So if you have any questions or want to know any more in-depth look on the new open source languages or any other language that I talked today, tomorrow, same time, there is a session. It's 5BH, and we have a panel of experts there to answer your questions. So, if you have any questions, I strongly encourage you to join that session so that we can have a discussion, we can have a chat, with the experts that are actually building these kind of products. So I think we have about 2 minutes left. Is there any questions that?
I just want to say well done for persevering with the background noise there, Roland. It'd be nice to stay on and watch you go kill whoever it is doing that. Yeah.
Yeah, unfortunately, I live in a building, a condo building, and they're doing some work upstairs. So I just can't. Everywhere I go in my condo, I still hear the same noise.
Yeah, no.
I hope it's not too distracting for you guys. But
no, it was absolutely fine. Got a little bit noisy at the end there, but no, it was fine. We could hear you loud and clear. So listen, yeah, an excellent presentation. I found it really useful for me, for sure. Certainly that last slide there puts it all into context. And good shout on tomorrow's session. Yeah, please do join us for that if you can. So it looks like we're all clear on the questions front. Yeah, good shout. Don't forget to submit feedback for this session. Feedback's always much appreciated. Don't forget the session tomorrow at the same time with the Ask the Experts panel. And we're back on the air in about half an hour's time with Steve Warren talking about encrypting coupling facility structures. So hopefully see you then. And with that, wish you a good afternoon. Thanks again, Roland. Very much appreciated. And hopefully see you all again soon.